Good morning, my dear students. Now we are going to talk about Unit 3 fluids. First one, pressure. What is the pressure? The effect of thrust per unit area is called pressure. The effect of thrust per unit area is called pressure. Pressure equal to thrust divided by area. Pressure equal to thrust divided by area. Unit Pascal. Pressure unit Pascal. 1 Pascal equal to 1 Newton divided by 1 meter squared. 1 Pascal equal to 1 Newton divided by 1 meter squared. What is the thrust? The force applied on a surface in a direction perpendicular to the surface. The force applied on a surface in a direction perpendicular to the surface. Unit Newton. Pressure depends on two factors. First one force and another one area. Force, first one thrust. More force, more pressure. Second one area, more area, less pressure. What's the pressure and pressure in fluids? The pressure at a depth h below the surface of the liquid is due to the weight of the liquid above it. We can quickly calculate P equal to para GH. P equal to para GH. This reaction is valid for any liquid whose density does not change with depth. Next one important question, mercury parameter. Made by inverting a long glass tube filled with mercury. First one, made by inverting a long glass tube filled with mercury. Due to the inversion, a vacuum is created at the base of the tube and a column of mercury is supported by the atmospheric pressure. Due to the inversion, a vacuum is created at the base of the tube and a column of a mercury is supported by the atmospheric pressure. The units for the measurement of atmospheric pressure can be in terms of centimeters of mercury or Pascal. Another unit of pressure is tar, where 1 tar is equal to 1 millimeter mercury. Listen, mercury parameter. It has been shown that atmospheric pressure supports a liquid column in a tube. When this arrangement is used to measure pressure, it is called a parameter. At sea level, a column of mercury and water supported by atmospheric pressure is approximately 76 centimeter. Yes, buoyancy and Archimedes principle. This is an object submerged in a fluid. There is a net force on the object because the pressures at the top and bottom are different. The buoyant force is found to be the upward force on the same volume of water. Fp equal to F2 minus F1. F2 minus F1 equal to para F GA H2 minus H1. H2 minus H1. PF para F G A del H. H2 minus equal to del H. Therefore, P para F VGH. Therefore, MFGH. Absolute and cage pressure. What is the absolute pressure and cage pressure? First one, atmospheric pressure. Pressure exerted by atmosphere. Cage pressure, pressure more than atmospheric pressure. And vacuum and negative pressure, pressure less than atmospheric pressure. And absolute pressure is called pressure measure related to absolute zero. Okay, pressure atmospheric pressure equal to absolute pressure equal to pressure atmospheric pressure plus cage pressure. Pressure APS means absolute pressure equal to pressure atmospheric pressure minus pressure vacuum pressure. What is the cage pressure? This pressure is referred to as cage pressure. It is not to the total pressure at this depth because atmospheric pressure is applying pressure at the surface. Absolute pressure P is calculated. P equal to P naught plus para psi G. P naught is atmospheric pressure. Atmospheric pressure and cage pressure. Most pressure cages measure the pressure above the atmospheric pressure. This is called cage pressure. The absolute pressure is the sum of the atmospheric pressure and the gauge pressure. P equal to PA plus PG. And measurement of atmospheric pressure. It's a mercury parameter. The parameter works by balance the mercury in the glass tube against the outside air pressure. If the air pressure increases, it pushes more of the mercury up into the tub, and if the air pressure decreases, more of the mercury drains from the tube. As there is no air trapped in the space between mercury and the closed, and there is vacuum in that space. Vacuum cannot exert any pressure, so the level of mercury in the tube provides a precise measure of air pressure, which is called atmospheric pressure. This type of instrument can be used in a lab or weather station. On a typical day at sea level, the height of the mercury column is 760 millimeter. 760 millimeter. Let us calculate the pressure due to the mercury column of 760 millimeter, which is equal to the atmospheric pressure. The density of mercury is 13,600 kilogram meters pressure. Pressure equal to HPG. Law of flotation is very important. 3 more question. Law of flotation. The weight of the flotation is equal to the weight of the liquid displaced by it. The center of gravity of the floating body and the center of gravity of the liquid displaced are in the same vertical line. Stability of floating bodies. The equilibrium of a free floating body is said to be stable. If on being slightly displaced, the body returns to the original equilibrium position. Consider a floating body in equilibrium. G is the center of gravity of the floating body and B is the center of buoyancy. The line PG is vertical. Students, watch this video 2 or 3 times so that you can understand the concept well. Today's homework in science, 3 questions. Write law of flotation and explain mercury parameter and define thrust and pressure. Here I give 3 questions for you. So you have to think and answer. You have to think and answer these questions and write this question and answer 3 times in your homework note, and also write this in your science test note and send it to my personal WhatsApp number. Thank you, students. God bless you.